5, it says some binary compounds that form between fluorine and various nonmetals are listed in the table above. A student examines the data in the table and poses the following hypothesis. The number of fluorine atoms that will bond to a nonmetal is always equal to 8 minus the total number of electrons in the nonmetal atom. Based on the student's hypothesis, what would be the formula for the compound that forms between chlorine and fluorine? Well, since chlorine has 7 valence electrons, you'd have 1 chlorine. It would be ClF because you'd have just 1 fluorine since 8 minus 7 is 1. In an attempt to verify the hypothesis, the student researches the fluoride compounds of other halogens and finds the formula ClF3. In the box below, draw a complete Lewis electron dot diagram for the molecule ClF3. So when you count out total number of valence electrons, you'll get 28. So it's going to be an expanded octet, and you draw it that way. So you get 1 point for having chlorine as your central atom with 3 bonding and 2 non-bonding. In C, it says 2 possible geometric shapes for the ClF3 molecule are trigonal planar and T-shape. The student does some research and learns that the molecule has a dipole moment. Which of the 2 shapes is consistent with the fact that ClF3 has a dipole moment? Well, if it has a dipole moment, that means it's polar. The only shape there, trigonal planar versus T-shape, that is polar is going to be T-shaped. Okay, and you can say T-shape because it's asymmetrical, or you can say T-shape is polar because the dipoles do not cancel out. In an attempt to resolve the existence of the ClF3 molecule with the hypothesis stated above, the student researches the compounds that form between halogens and fluorine and assembles the following list. Based on concepts of atomic structure and periodicity, propose a modification to the student's previous hypothesis to account for the compounds that form between halogens and fluorine. So one thing you could say is as the atomic number of the central halogen increases, the number of fluoride atoms increases, right? So, or as you move down the periodic table, right, as the size of the atoms, the central atom increases, that could cause the number of atoms to increase. You could say that. And I'm honestly not sure what they were talking about for number 1. If you understand it, awesome. But just talking about some way of being able to predict the number of fluorines that are bound to your halogen. Okay? So you get 1 point for some sort of hypothesis that works.